I have recorded for some other group, so I can repeat the same process for you, so that I can save some something like 30 minutes, 30-40 minutes of live what I would say broadcasting. Instead of talking, I would replay that audio, and then it's a video, basically video file. So there I am going to demonstrate concepts much better. So let's continue with what is called now the measurement. So in the previous class we started with the measurement, and then this is our popular slide. So very frequently we will see this popular slide, where are you now? Because every time I'm displaying this slide, you would know where are you today. So we are not very far away from concluding steps. But I know acquiring empirical data itself is taking something like 7 to 8 hours. If you had counted how much of time we had spent so far, we had seen so far what is called sources of data, tools and methods of data collection, and now we are seeing what is called what is that called concept of measurement, and then we will see how to construct a questionnaire. Then we'll see how to upload that. I'm going to demonstrate uploading of the questionnaire. We will see that all tomorrow, and then based on tomorrow's time availability, we will start with the concept of sampling. So that's the flow of topics today, for especially in acquiring empirical data as a step. And once that is done, we are going to install software. So get ready. I think it would happen from next week. So next week, fresh, we're going to start with analyze and evaluate the data. So on an average, that's what we will do. Very promptly, we'll start the sessions from subsequent as we did it today. So we will not lose much time. Sharp 11:30, we'll start the class, and then we'll continue until 2 o'clock with a short break. But you can avoid those breaks, because continuously sitting is also definitely tedious, and then you're also taking notes. That's also very time consuming and then taxing. So I'm sure we have to bear with all these technological issues, and there's no other way of moving forward. So nothing stops us now. So let's move on. So we had seen what is called sources, methods, and tools of data collection. And then today we are going to see, we are almost concluding what is called concept of measurement. We will also see reliability and validity today itself. And then tomorrow's class is going to be on sampling. Remember that. And since we are not going to spend much time on sampling because you have already learnt it in the previous semester, so I will do only brief note or brief presentation on what is called sampling. But I'm going to show you something on practical aspects of sampling, not that mere theory. So some demonstration of each sampling method. How do we actually select the samples, particularly during this lockdown? And then how do we choose them using scientific methods? Then how to contact them, all that happens subsequently. So I think by tomorrow we will be concluding acquiring empirical data, if everything goes well, because I have to demonstrate. I don't think tomorrow, sorry, I don't think tomorrow. So tomorrow we are going to show how to construct a questionnaire and also how to upload it full full time. So right from 11:30 onwards, we until 2 o'clock, we will see how to design a questionnaire and how to upload it. In fact, how to design a questionnaire for my topic, because I'm demonstrating my topic only all through. So tomorrow I'm going to show you how to design what you call a questionnaire for my topic on conflicts and satisfaction among hospital employees. And I'm sure you're also trying. So don't be silent on that, because if you're silent, you're not learning. So finish your projects, get back to me. Don't hesitate, and clarify whatever you have doubts, so that you are progressing. There's nothing called non-availability of topic. There are literally thousands of topics. In fact, you will be lost in the choice which one to choose. So I think you should finish off now. It's been almost a week's time. You have not done it so far. So kindly do that, and then we will refresh now on concept of measurement. In the previous class, we talked about the importance of measurement. Without measurement, you will never know the results. That's what, plain simple. Without measurement, you cannot measure the results. You cannot demonstrate the results. You will never know what is called success from failure. So therefore, that's the power of measuring. And we had also seen why is it so important, because as a student of management, you must know that without measurement, you cannot manage. Definitely not. Without measurement, you cannot manage. Measurement is the foundation of any scientific investigation. Without this measurement as a foundation, you cannot translate all your research into reality. Impossible. So therefore, everything begins with measurement. And how do we define it? Yesterday we had seen it's a process of assigning numbers to the values of a variable. So what are the values we had seen? Values are the answers. Variable is called the question. That is all common man's explanation. But there are certain rules that you follow in assigning these numbers. So in order to do so, we have also seen yesterday what are the qualities of a good measurement. So the first quality is called equivalence, second one is called order, third one is called fixed interval, and the last one is called true zero. These are the qualities that you can see in any variable of its values. So these qualities are applicable to the values of a variable or the responses of a question. So all the answers to a question should have these four qualities. If the answers do not have all these four qualities, that answer and that question is not a good measurement. But unfortunately, we have not so good measurements. There's nothing called bad measurement. There is something called weak measurement, but there's nothing called bad measurement. So, but I think that is not the right phrase. I should have said qualities of a perfect measurement. Instead of good measurement, I should have said perfect measurement. So a perfect measurement will have all these value qualities. Equivalence, that means the answers are mutually exclusive. Order, one answer is greater than the other answer. One value is greater than the other value. One value is lesser than the other value. That's called order. Then fixed interval, the distance between these values is equal to the distance between the subsequent values. And then true zero is the zero which has a mathematical value which is dividing the answers before zero and answers after zero. I have given some examples, so we will see more today. More examples we'll see so that you will be able to design your questionnaire better, because every question that you put in your questionnaire will follow these qualities. You will know exactly whether the question that you are putting, whether the answers that you have framed fulfill these qualities or not. We will follow that procedure. So therefore, let's slowly move now into the uh, additional concepts that we will be using. So what is a variable? What is a construct? A variable can take characteristics that can have more values. So for example, as I told you, gender has only two values or three values now. Since last September 2019 September, our Supreme Court had given what you call relaxed that article. I don't remember which article is that, article 170 or something like that, where every gender is given freedom to function, freedom to identify themselves. So the third gender is now officially a gender. Otherwise, all these years we were having only two genders. So the third gender, transgender you call, they are also now recognized. So in a gender you have three values, whereas for age you have continuous values. So a variable can take continuous values, whereas gender, if you take gender, gender cannot be a variable because it is an attribute. Why is it called an attribute? Because attribute will not have more values. Attribute will have fixed values, but interchangeably we use attribute and variable. Gender is an attribute, whereas variable is continuous in nature. It has so many values, sometimes infinite values also you can find. So, but certain variables which have fixed values, such variables should be called attributes. But for our convenience, we will not change them, distinguish them. So we can even say attribute is a variable because at least it has some values. So, but variables are also classified into independent and dependent. There's a third category of variables called mediating variables or moderating variables. So, independent variables, dependent variables, moderating variables, mediating variables. So, you have four types of variables. Now let's go to next concept called construct. What do you mean by construct? When a concept is operational, it becomes a construct. What does it mean? For example, if you want to measure conflict, conflict is a concept. How can you convert it into a measurement? So a conflict can be called a concept. It becomes variable only when you say degree of conflict, level of conflict, extent of conflict. So which means you're bringing the concept of measurement into a concept. When a concept of measurement is brought into a concept, it becomes a construct. So a concept has to become a construct. So variables also are constructs in one sense. So with that we move on now with this clarification, some more definitions of more demonstrative definitions we'll see. Now what is a variable? A variable will have characteristics or values. We used values always. Now we can even use the word characteristic. A variable can have more than one characteristic. For example, you see gender. Gender you have female and male. Now transgender. Third characteristic is also added. Now, what are the qualities of the variable? We have already seen them. A good variable should have mutually exclusive, then what is it called? Equal spacing or equal distance, or it is also called fixed interval. Then it has order. Then it also has what you call true zero. So I'm just emphasizing these two qualities here. Now, having seen the qualities of a perfect measurement, now we will see in the definition what are those called rules. I'll go back to that slide now. If you go back to the definition here, you can see in the definition you have something called measurement is the assignment of numbers to the objects with rules. Underline this word rules. Now I'm going to explain what are these rules and why you should not give numbers as you want. For example, gender, male is equal to 1, female is equal to 2, transgender is 3. Why did you give 1, 2, 3? I don't have answer. But if you have an answer, it is called a rule you have followed. So what are those rules? So we'll straight go to those rules now. The first one is called nominal, second one is called ordinal, third one is called interval, and the last one is called ratio. So instead of using the word rules, I'm using the word levels because that is the standard name for it. Levels refer to the severity or the degree. Higher level, high perfect measurement. Lower level, weak measurement. So therefore, a measurement, if it has four qualities, is called a perfect measurement. And there are four levels of measurement, or you can even say four types of measurement. I think that's a better way. But standard labeling is called levels only. So nominal means least level, ratio means highest level. So what are they? I think now we will see each of them carefully. Let's start with levels. These levels convey the relationship of the values that are assigned to the attributes or a variable. Attributes are a variable of a variable. The values that are assigned to the attributes of for a variable. So what are the values that were assigned to the variable and how many values are there and how these values are related to that variable? That's what we call the level. So some are related, some are not related. For example, you can see how the values are on a variable. So if you take gender, you have 1, 2, 3, let us assume. Or you can even take any other example. Political party. If you take political party, what are the values it has? It has, let us say, three values, 1, 2, 3. And these values establish a relationship to the variable. Similarly, now you can see in this slide what is a variable. what are its characteristics, and how you translate them into values, which are also called numbers in one sense, and how these values are related to each other and also to the variable. So now this relationship is referred to as the levels. Now we will see each of those relationships, because without these relationships or without these levels, you will never know what statistical test to design or adopt. Which test should I use? If you don't know the levels, it's impossible to know those statistical tests. So that's the important point. Not only that, if you don't know the levels of measurement, you will never know how to interpret the data from that variable. So what does that 1, 2, 3 mean for gender? What does that 1, 2, 3 mean for political party? It's very difficult to interpret. So, but if you have those numbers assigned with certain levels, levels also means rules, it becomes easy for you to interpret. So that's how these are. So now we'll start with the first one called nominal measurement. You can write down some points on this. Nominal means the name, or nominal also means merely, merely, or in India we say just like that. So merely or just for the sake of name, we give numbers to the values. Now these values do not imply any order. So they don't have any order. You cannot classify them according to an order. For example, if you take gender, male is equal to 1, female is equal to 2. Why did you give 1, 2? Just like that. That's a typical Indian style. Or why did you assign those numbers? Just for representation. But I'm not going to do any calculations on those 1, 2, 3. That's the meaning of nominal. The numbers that we assign to the values of a variable or the attributes of a variable do not have any mathematical property. That is the meaning of nominal. Then why did you give numbers? Those are given only for the sake of representation. Just for the sake of representation, I am giving those numbers. So I have an example here. For example, in a football, you have, let us say, number of players. So everybody is given a number. For example, you can find these numbers on their t-shirt that they wear. So somebody's number is 32, somebody else's number is 19. It doesn't mean that the player who's got 32 t-shirt is higher number than the player who's got 19. These numbers are called nominal. They are just given for the sake of mere identification, but they don't have mathematical value. That's the meaning of it. It's not a scale because it does these values do not have any mathematical property. Similarly, in case of gender, you see male is equal to 1, female is equal to 2, the transgender is 3. Hereafter, we have to put that example. These 1, 2, 3 do not have any mathematical value. What does it mean? Male is equal to 1, female is equal to 2. So 2 doesn't mean it is greater than 1, or 1 doesn't mean it is lesser than 2. That's the meaning. I hope so far we are clear on this front. So gradually we'll move now. Take this another example, religion. So you have Hindu, Protestants. This is an international example. So Hindu, Protestants, Jewish, Muslim, and others. Because Hinduism is the second largest religion in the world, followed by Islam and then Christianity. But here you can see there are also Jewish religion. So therefore, in a country where you are conducting a study, you would know who is the predominant religion representation. So therefore, Hindu is equal to 1, Protestant is equal to 2, Jewish is equal to 3, Muslim is equal to 4, and others is 5. In other words, these data could also be called categorical data. Why? Because I don't have anybody between Hindu and Protestant to tick. I don't have anybody between Protestant and Jewish to tick. I don't have anybody between Jewish and Muslim to tick, and similarly on the other categories. That's why it is also called categorical data. You can imagine I cannot fix anybody between 1 and 2, 2 and 3, 3 and 4. If someone says I'm partly Hindu, partly Christian, where will you keep that man? Because that's possible. I remember my professor made a statement once. I remember long ago he passed away. In a informal discussion with him one evening, he said, "Chandrasekhar, uh, I am a Hindu by my thought, my brain. I am a Hindu by my brain, and I am a Muslim by my body practices, cleanliness and all that, and I am a Christian by my heart. So you tell me what kind of religion he belongs to? Where will you put this man?" Sometimes you'll find people like that. Others could also mean atheists or uh, agnostics. Atheists and agnostics fall under that category called others. I think we can move further to another example. In the psychiatric department, someone's depression levels are assessed. So 0 is none, 1 means mild, 2 means moderate, 3 means severe. What do you mean by this scoring? Can you call it an order? Is there an order in it? 0 has a less, 0 is lesser than 1, 1 is lesser than 2, or 3 is more than 2. That's the way values are given. So this is an example of next level called ordinal measurement. When values are ordered or ranked, that's what we call ordinal measurement. The distance between the values do not have any meaning because the ranks are ordered, that's it. But you don't have the distance between them. For example, go back to the same example. Someone can be mild in depression, someone can be moderate in depression, and someone can be severe in depression. Can you find somebody between mild and moderate? Can you find somebody between moderate and severe? So it's not possible to tick an answer there. So four are fixed categories, but they are ordered. There is a ranking. Whereas in case of gender, there is no ranking. In case of political party, there is no ranking. But here there is a ranking because of the degree of depression somebody is having. So that's why ordinal measurement. This is level. This is the second level. Now similarly, if you take educational attainment as an example, 0 is less than high school. 1 means some high school education, 2 means plus 2 or degree, 3 means some college, 4 means UG, 5 means postgraduate. So there is an order here, you can see some degree, some order. So 5 is greater than 4, 4 is greater than 3, 0 is lesser than 1. That's the way the message is. So there is an order, that's what ordinal measurement talks about. But I want you to explore, is there a distance between this order? For example, someone has got 0 less than high school and someone is 1 is equal to some high school. What can be between 0 and 1? Or what can be between 1 and 2 here? I don't think anything. Even if I put like this, uh, up to SSC, 0 is up to SSC, 1 is plus 2, 2 is plus 3. Can I put between 1 and 2 now? Someone is plus 1, someone is plus 2. So between plus 1 plus 2 there is nothing possible. But there is an order: juniors, seniors, first year course, second year course. So there is an order, but you cannot have anybody between these two orders. I can also give another example: classroom performance. Somebody is a top ranker. I hope I have that example. No, I don't have it. Someone is a top ranker in the class. Someone is a second ranker. Someone is third ranker. Someone is a 10th ranker. So between 10 ranks, you can have only people distributed. Some people could be having top rank, first class. Some people could be having second ranks. But tell me, is it possible to keep somebody between first rank and second rank? Could somebody get 1.5 rank? Could somebody get 1.3 rank or 1.9 rank? Not possible. That's why in ordinal measurement, you don't have equal spacing or fixed intervals. You cannot find fixed intervals. The values are mutually exclusive. First ranker, second ranker. First ranker cannot be second ranker. Second ranker cannot be third ranker. They are mutually exclusive. That is what we call uh, equidistance or equivalence. Sorry, equivalence. But they don't have equal spacing or fixed interval. The distance from 0 to 1 is the same as distance from 3 to 4. It cannot be, no? There is no distance actually. You cannot measure the distance between 0 and 1. If it's possible, then you can put some other respondent between 0 and 1. So it cannot have the distance. Now you can find the distance in interval measurement. When distance between attributes has a meaning. So for example, you take a temperature measurement, you can find between 30 and 40, there is a distance. Between 70 and 80, still there is the same difference of 10 units. That's why classic example could be this. And you can even have sometimes this example is relevant to ratio scales also. They use this example because ratio scale and interval scales are very closer to each other except for one difference, that is 0. In an interval scale, you cannot find a true 0. I hope you are reading this. Ratio don't make any sense. That is 80 degrees is not twice as hot as 40 degrees. You will know they are not like that to be interpreted. What is the difference is there is a 0 which deviates, distinguishes the temperature. If you go back to interval again, uh, instead of temperature, you take age as an example. If you take age as an example, somebody's age is 1 year, somebody else's age is 2 years. So the distance between 1 and 2 is 12 months. And that distance is equal or it is same as the distance between 2 and 3 years or 3 and 4 years. What is the distance between 1 and 10 years? Anybody? 10 into 12. That's the distance. Similarly, what is the distance between 10 and 20? Same as the distance between 1 and 10. So in interval measurement, you can have equal distances and therefore fixed interval. The intervals are very fixed. 12 months is a fixed interval. 7 days is a fixed interval. 30 days is a fixed interval. So therefore, in a ratio measurement, we have that absolute 0 that establishes the relationship between values of the variable. That absolute 0 we talked about yesterday also, a 0 which distinguishes the what you call values before 0, values after 0. Now I'll give you another example you can note down. In our country, it is very relevant example. Um Indebtedness. 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 What do you mean by that? Someone who is in debt, someone who borrowed money from somebody else and he owes that money to that somebody. So that's what we call indebtedness. Now, indebtedness is also called the income generated from loan is called minus income in economics. The loan that you had borrowed from the banks is called minus income, which means it's not your income. Income is positive, you have earned it. But when you borrow the loan, that is minus income, which means you have to pay that back. It is not yours. So therefore, income is another example for ratio measurement. As an unemployed student, you don't earn any money because you don't have a job. But when you have money on your pocket, it is borrowed money, which is called minus income. So which means unemployed people should not be having income, so therefore their income is zero. But when they have money, when they borrowed money from their parents or their friends, that is called minus income. So that is below zero. But when they start earning, it will be plus zero, zero plus. So that's how income sometimes or indebtedness is an example of ratio measurement. I'll not give much examples anyway. So now we will move on with the final judgment. Which measurement is better? In fact, you can also try. I will skip this slide. What you do, you try that out. Which measurement fulfills all the good qualities? Four good qualities. First one, nominal. Second one, ordinal. Third one, interval. Fourth one, ratio. And the qualities, one is equidistance, or sorry, equivalence, sorry. First quality is equivalence. Second one is order. Third one is fixed interval. Fourth one is true zero. So I'll display that now. You can see nominal measurements, they have equivalence, but they don't have the other three good qualities. Whereas ordinal, they'll have equivalence and order. Whereas interval, it has all the three qualities. And the last one, ratio, it fulfills all the four qualities. So therefore, what do we declare? Ratio is the perfect measurement. Then interval scale or interval measurement is the near perfect measurement. Somewhere you can write down in your notes. Interval and ratio put together is called scale. Both interval and ratio put together is called scale. In many software, they will show nominal ordinal but not the other two, interval and ratio. So instead of that, in the softwares, most of the software programmers would display what is nominal, what is ordinal, and the last two put together named as scale. So let's pause for a while before I move into the next point. If you have any doubts, you can put them on the live chat. Can you hear my voice, everybody? I hope you can hear my voice. Naveen has some problem, I think. I think your bandwidth problem, I think, Naveen. Cross check it. Yeah. Thank you, Anita. So in this, yeah, thank you. So what we see finally, we can even see, I will show you more elaboration, more illustrations from the next slide so that you can have much better grip over, because in your questionnaire design, you might be using all of these measurements. For example, one question may be nominal, another question may be ordinal, another question could be interval, another question could be ratio. So the entire questionnaire will have these four, or you can have more nominal, you can have less ordinal, you can have some number of interval, very rarely you would have used ratio. It varies. Suppose for example in HR, if you're doing research on HR and marketing, you might use 1 and 2 more, occasionally interval. Whereas in operations and finance, you will use more ratios and interval. For a lot of primary data, you will use nominal ordinal and less interval. Whereas for secondary data, it will be more ratio and interval. So that's why also we can distinguish both of them. I hope the message is clear. So what we'll do now, we'll slowly get into the next point and then we'll summarize each of them again. So the four levels of measurement, which are also called primary scales one way. So let's not worry about that heading. The first one is nominal. Now we are getting into the summary of this measurement concept. The first one is nominal. Numbers are assigned to the runners. That was the example we had seen. So this is the 17th player, 21st player, 13th player until they go to the last number. So, but these numbers do not have any mathematical values. That's why it's called nominal. Whereas ordinal, the winners are ranked. For example, you also ask patients in the order of your preference, how do you rank your satisfaction? For example, how satisfied are you with the doctor? How satisfied are you with the nurse? How satisfied are you with the diagnostics? How satisfied are you with the uh, what you call food and beverages? How satisfied are you with the billing? How satisfied are you with the pharmacy? How satisfied are you with the security? How satisfied are you with the messengeril staff? How satisfied are you with the hygiene or cleanliness? How satisfied are you with the costs? So you can ask them to give a rank for each of them, which is the top satisfying dimension. So we can even say first place, second place, third place for those dimensions based on the ranks given. So that's why ranking, any question which is obtaining ranks is called ordinal measurement, or any question which is asking consumers preferences, patients preferences, patients choices. These kind of questions are all called ordinal questions and ordinal measurements. Whereas interval measurements, where you have the values having fixed interval, they continue. The values could continue from 0 to 100, let us say, on a performance scale. So somebody could score between 0 and 100. That's continuous scale. It's also called continuous number. So that's the unique characteristic of interval scale. Whereas in case of ratio scales, as I told you, there will be a true zero. So you can have the scores below zero and scores after zero. And then you can also have them, that's what in fractions you can have. The example is time to finish the race. So you can even go by seconds. Sometimes you would have noticed in some entrance exams, there is something called minus marking. So what is called minus marking? Instead of getting 1 mark, you might get minus 10 marks. That means you lost the 10 good marks. So that kind of scoring is also called ratio level. Does it make any sense to all of you? I hope. So every question could be either nominal, ordinal, interval or ratio. Every question virtually. Tomorrow you will see that when I am demonstrating them. Tomorrow's class is called demonstration steps followed in construction of a questionnaire, and then demonstration of the construction. So first we'll see what are the steps involved, then we'll see how to design it, how to design a questionnaire, and if time permits, how to upload it online. I'm going to demonstrate that in real case. This will be a real case, how to upload on Google or how to upload on any other services. There are a lot of services available in online where you can upload your questionnaire, generate a hyperlink, and send it to your sample respondents as email. So when they open the email, they'll get a hyperlink. When they click that hyperlink, it will open some other server page, and there your questionnaire is displayed, and they can read each of those questions and answer them there itself. And when they press the submit button, you'll get a reply that somebody responded to your questionnaire. And then you can go to your own server, you go to your own web page and check up how many people have entered responded to your questionnaire today. So every end of the day you have to see that for next 10-15 days, then you will know how many people have responded. If the response rate is poor, you have to again send them emails requesting them again. Sometimes in India you have to do that, repeatedly request people, then only they'll do the work. Unlike Westerners, once you send a request, they will honor or reject it. They'll say, I'm sorry, I cannot do it. Or they'll say, I'm doing it. And then they do it. That is the Western mind. Whereas in India, we always say that we will do it, but we don't trust, we don't depend on our own stand, our words. That's a peculiar Indian culture. So now we will move on to the elaboration now. Nominal scales are the weak scales because it just the characteristics are merely for namesake. The values are assigned to the variables. The numbers assigned to the values are only namesake. Ordinal, the characteristics can be ordered, and in the interval, you have an equal distance between the value characteristics, and then the ratio, there is an absolute zero. So this is the way you would know. That's why they are called levels of measurement. Ratio occupies the highest level, unlike interval, ordinal, and nominal. So now we are moving into next theme called special scales. Now we have seen what are the four levels of measurement. Now we are going to see some special scales developed over the time. Some special scales were developed, which means they could be either nominal, ordinal, interval, or ratio, but they were developed specially for certain purposes by some professors in the past. And that's a very, very important point to you, because when you are designing your questionnaires, you might follow these special scales. And by the way, what is a scale? You know that high school centimeter scale that you had used to draw the lines in your notebook. And then when you go to a tailor for getting your cloth stitched, he uses a scale for measuring your waistline, your muscle line, your collar lines, your pant length from waist to the ankle or waist to the toe. They measure it. That's called a scale actually. So a scale involves creating a continuum upon which measured objects are located. So every unit is called an object. So you locate all those units on a scale. That's what is called scale, centimeter scale or inch scale. For example, if you want to measure an attitude, you should have a scale for it. For example, if you want to measure opinions, you must have a scale for it. If anything, any concept that you want to measure, you must have a scale for it. Whereas in physical sciences, you have centimeter scale. You can measure it in feet. You can measure it in kilometers. Any physical phenomena can be easily measured. with those scales. But what about psychological phenomena? We have so many like that. Patient satisfaction is not visible. How do you measure it? You need an exclusive scale for it. So when respondents answer to that scale, let's say 100 people answer to that scale, you would know exactly how each of these 100 has answered to that scale. Which one did they tick? You would know them. So when you group them according to the ticks that they gave to that scale, you can classify them later on into one is extremely unfavorable and the remaining are extremely favorable. So therefore, scale is the process of placing the respondents on a continuum. Continuum means one point to the other point with respect to their attitudes towards whatever. We are taking here example as department store. I'll give you some examples on that. So what is your attitude towards hospital can be measured with the help of a scale. What is your attitude towards the parents? What is your attitude towards lockdown? What is your attitude towards the government? If you want to measure those, you are actually using some special scales. So we will see what are they now. I think 1 minute break you can have. You can have some water. You can have some snacks. Just 1 minute before we start with each of the scales. I will also have some water. Hello Chakravarti. Hello. చేశాను. ఇది నీ దగ్గర ఎంత ఉంది నీ దగ్గర ఎంత ఉంది? అవును. నో ప్రాబ్లం. పర్లేదు నేను మొత్తం చేశాను. సేవ్ కూడా చేసేసాను. నో ప్రాబ్లం. ఎక్కడ పోదులే. నీ దగ్గర ఎంత ఉందో అంత పంపించేసి. షూర్ షూర్. సరే చక్రవర్తి. రైట్. पानी हो गया. I hope the message is saturated on your minds on what is called the concept of measurement. And now it's time for us to start with certain special scales that were developed during the last 60 years. And this time we are taking some of the names of the professors who had developed them, and therefore you can also use their scales in your project reports. So what are these special scales? A word of advice before we start is these special scales are all ordinal scales. You can write down somewhere. All are ordinal. So ordinal scales are very popularly used even though they have some limitation. I guess my voice is clear because I'm going to look through very crucial topics. So all special scales we are referring to. Every scaling technique that we are going to see now is an example of ordinal scale, which means the values of a variable have an order, but they don't have equal space. Though they are mutually exclusive, the values have greater than, lesser than value, but they don't have fixed interval, they don't have true zero. So it fulfills only first two characteristics. What are they? Number one, equivalence. Number two, order. So let's start with them. So there are two types of scaling techniques that we normally come across. First one is called comparative and the second one is non-comparative. What do you mean by comparative scaling? When you want to compare the values of a variable or variables or objects, when you want to compare the stimulus of objects, then you are actually using comparative scales. Whereas when you are measuring the values of a variable for an independent purpose, you are not comparing, in fact, you are not comparing two objects, and therefore it is called non-comparative scale. We have examples there. When you want to compare, you are asking people to compare what is Pepsi and Coke on taste or sweetness. So you are measuring sweetness, you are asking how Pepsi compared with Coke on taste called sweetness. So people give answers, comparative answers. Pepsi is more uh, less sweeter than Coke. That's the way we can explain. Similarly, if you want to just ask how sweet is Pepsi, then that's called non-comparative. So that's why you have to be very careful when you're preparing or designing your questionnaire. Or each question has to be carefully thought over. Now we have various types of scaling techniques, namely Likert scale, Thurston's scale, Gutman scale, and semantic differential scale. I'll repeat them. These are all the names of the professors as I told you before. Each of them is developed by a professor. So very popular one is called Likert's scale. And let me also give you the background. You can also search for the background on the internet later on. These scales were developed for measuring psychological variables or psychological concepts. When you're asking your patients how are they feeling, you're actually using scales like this. If you're asking a patient how satisfied is he, you're using one of these scales. Patient's choices, patient's preferences. Patient feedback on the quality of services. If you want to conduct a study, one of you would have taken a topic like that. Quality of services and patient satisfaction. Somebody could have taken a topic called waiting time and patient satisfaction. Somebody could have taken a topic on communication and satisfaction, how doctors communicate with patients and therefore how satisfied are the patients. So, doctors' communication and patient satisfaction can be a research idea. Why certain patients prefer your hospital? So, preferences for hospital and patient satisfaction can be another area, another research topic. So, there are hundreds of topics. Either you are a rational thinker or a creative thinker. If you're a creative thinker, you are struggling to generate a topic. If you're a rational thinker, it is very easy. Simply go to Google and type. You'll get lots of topic titles. But that's what you have to make a choice between these two. Do you want to be a creative thinker or rational thinker? I guess you're all struggling to be creative thinkers because since Monday, actually, you are supposed to submit your topics on Monday. Today is Thursday, so Monday, Tuesday, Wednesday, Thursday, and I don't think so far anybody had sent the mail to me. So last 4 days you are struggling to generate a topic means you are all creative thinkers. Unfortunately, there is no productivity. If you had been a rational thinker, I am sure on Monday itself you would have got a topic. But I am not discouraging somebody from being creative. It takes time to create, no doubt about it. But how long is a big question. You cannot create a vaccine after everything becomes routine. So if everybody gets used to this virus after next 6 months, who will buy this vaccine? That's what happened to SARS and MERS. That's what happened to hepatitis B. Nobody buys that vaccine today. Vaccine for yellow fever. Who will buy that? Only those who want to go abroad. So, but companies spend billions of dollars on developing vaccines. After developing, nobody uses it. The company will come closed. It becomes sick. That's so dangerous developing vaccines economically for those companies. Same thing happened to the other viruses outbreaks in the past. We have vaccine for SARS. Nobody uses them any longer. So with that pre-note, let us explain each of them. So we'll start with Likert. By the way, his full name is Rensis, Rensis, Rensis Likert. He was the first guy to develop a, an ordinal scale or ordinal measurement for measuring attitudes. Likert's scale is also called summated rating scale. And this scale will have 5 categories of responses. As you want to ask people uh, their response, how favorably or unfavorably they react to an object. For example, if I would ask you, uh, this hospital has got good doctors, if that is a question, the answers could be strongly agree, agree, neutral, disagree, and strongly disagree. There are 5 responses. So you can say that I am quite satisfied with this hospital services. You are asking a patient's attitude actually, and the answers would be agree, disagree, strongly agree, agree, neutral, disagree, and strongly disagree. So you can see this is called the continuum. Strongly agree to strongly disagree is called continuum of a scale. So now anybody can answer. How will you assign numbers to these values or attributes? Strongly agree is a positive answer, so it should be given 5 points. Agree is the next positive answer, but lesser than the first one, so I'll give 4 points. So you find there is a greater than lesser than characteristic because it is ordinal. So 5, 4, 3, 2, 1, all those are ordinal, greater than and lesser than characteristics that they assume. But there is some, can you put anybody else between strongly agree and agree? Can you put anybody between agree and neutral? Not possible. But what you can do is you can expand. For example, strongly agree. Before strongly agree, you can have very strongly agree. And then the last one on the continuum, strongly disagree and then very strongly disagree. So it becomes a 7-point scale rather than 5 category scale. So you can have 7-point scale. So what is the clue here? Likert scales could have an odd number category of responses. Odd number, which means either you can have 3 simply agree, neutral, disagree, or you can have 5 odd number, or you can have 7 odd number, or you can have 9 odd number, or you can have 11 odd number. So the responses should always be in odd numbers. Remember that as your notes. So we'll give some examples now. I think self-explanatory. You can read it. Read each one of them on your own. So it's easy to express one's ideas. It's easy to have a good time at a party. One can usually keep cool in important situations. So these are all attitudes actually. And you're asking people to respond on a scale of 5-point scale called strongly agree, agree, undecided, disagree, strongly disagree. I hope you have understood how is it called ordinal. 5 is greater than 4, 3 is greater than 2, 1 is lesser than 2. That's called ordinal. So all these special scales are ordinal. That's the point I'm trying to convey. We move on to the next one called Thurston's scale. Another gentleman who developed it for measuring attitudes. Remember that most of these are for measuring attitudes. You can see how it is. When we are developing the scale, we are using a method of paired comparisons, and the responses will have equal appearing intervals or successive intervals. So it's basically you're comparing two things. That's what it conveys. So what are they? Go by the example. So when you take two comparisons like restful and inspiring, you're asking, I find the services of the hotel both restful and inspiring. And what is the response pattern? This is also ordinal: unfavorable, neutral, and favorable. How many responses are there? 11 are there. 11 refers to favorable service, 1 means unfavorable. Then 5, 6 could be neutral. But people can even tick 4, 3, 2, or 7, 8, 9 also. Less than favorable is 10. So respondents could tick. But the question is, why 11? Why not 5? More responses means that is going to be a good question. If we keep only less responses, it will become less reliable question. That will be, we will explain you after that 1 o'clock break. So 5 minutes break I'll give you exactly at 1 o'clock. So 1 5 will start the concept called reliability and validity of the scales. As I told you, every time the response pattern should be in odd number. Attitudes cannot be measured with even numbers. I can only give you one clue why. When you put odd numbers, you can see this distribution is normal. That's the clue. And when you take a graph, let us say scatter plot, you will see all the responses are like in a bell shape, normally distributed. But if you take even number responses, you will find your graph skewed to the left side or the right side. And that's why we will use uh, responses like this, odd numbered responses. Now we are moving into the next one called Gutman's scale. Another gentleman. If you are simply measuring one dimension or one concept, you would concept, that is attitude towards one concept, you will have this kind of a scaling called Gutman's scaling, which is also called scaleogram, or it's also called cumulative scaling. And the assumption is we are using only single dimension. You can see here. So in these hospitals, why hospitals cost is increasing is the reason. Here you can see money received from the customers or patients is very inadequate considering the service they ask to perform. So when they ask for a lot of things, and of course sometimes they don't know how to ask, so you only suggest them go do this, do this, do that, and they are very costly, and that's the reason they are paid. They are asked to pay more. So only peculiarity to distinguish is there are two answers. That's why it's called Gutman. If I don't understand much about Gutman scaling, I'll only understand by their answers. If you simply put agree and disagree, it's a Gutman scaling. Simple clue. I hope you're trying to understand it better. So we'll go to the next one called semantic differential scale. I forgot to put the author's name who had developed this scale. It is not one individual. There are three people. Three people have developed, and these are very, very popular scales. They are also ordinal. So what do you mean by semantic differential scale? I'll explain you that and also the author's names. First, write down the author's names. Uh, Osgood, 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 Tannenbaum, Tennenbaum, Tannenbaum, and Schmidt, Schmidt, Schmidt. So Osgood, Tannenbaum and Schmidt, they have developed this scale. It's very, very popular and we use this in hospitals more. For example, I remember at Apollo hospitals years ago, there were some three students who did a project. I still recollect, I still remember their project. It's because those days those students have done extremely hard work. I'm not seeing students working that hard any longer. I also blame the teachers because we are not putting heavy loads on you. We are pampering the students in this generation. That's why you are not hardworking people. So I blame the teachers. Mohit, I remember that boy. Mohit and two more students. I'm not able to recollect them. Mohit and two more students. What did they do? They have measured the image of Apollo hospitals across the country. So there are four hospitals, right? That time I remember Apollo Indraprasth, Delhi, Apollo Chennai, Apollo Hyderabad, and one more, I think. Not recollecting the city, but there are four Apollo hospitals in in the country that time, major mega hospitals. So what we did, we developed a scale to measure the image of the hospital in the minds of the patients, because hospital image is very important if you want to brand the hospital. Marketing subject, if you want to promote your brand, image understanding is important. So what is the image of people about the hospital in their minds? So for measurement of image we use semantic differential scale. They did it a wonderful job actually. In fact, we are all struggling to do these projects in one hospital in Hyderabad, but these guys have done it in four hospitals that time. So you can imagine how much of challenging those guys were. Mohit, I don't know where is he now. I think he is the junior of Dr. Ramesh or contemporary of Dr. Ramesh. He's not a Telugu guy, I think. He's somewhere from Uttar Pradesh or some other place. Never mind. So, semantic means words, English words, vocabulary. Differential means antonyms, words which are antonyms. That's why it's called semantic differential. So if you don't know what are called antonyms and synonyms, it's very difficult to design these scales. You can see, for example, if you want to measure how customers feel about a mart, a retail mart. So I gave a name here, K Mart. You have something like D Mart also. So if you are asking uh, customers how do they feel about this retail mart, it's such an easy way to design the scale. So you can have some adjectives first, or I would call them superlatives. Superlatives, certain words which I'm using to describe the mall. So pick up all the positive ones first. So if you have positive words to describe that mall, and then when you knew what are antonyms, you can use antonyms on the other side of the page. So on the left side you can see here, these are some words. The opposite are here, antonyms. That's why semantic means words. So you have words like, for example, this store is very modern. The opposite is old fashioned. Antonym. Low price, high price. Unfriendly stuff, friendly stuff. Narrow product range, wide product range. Sophisticated people come here, unsophisticated people come here. Sorry. So what happens when you put responses like this. In fact, each of them is a variable actually. They are not answers, they are variables actually. Continuum, this is called the continuum. One row, starting point here, ending point here. It's called continuum. And these are the responses. How many are there? 7-point scale. It's a 7-point scale. Odd number again. 1, 2, 3, 4, 5, 6, 7. Odd number. So therefore, you can increase more numbers, more words here. Sorry, you have about 1, 2, 3, 4, 5. So you can increase 5 more. You have 10. So with 10 variables, you can measure the image of a hospital. I can use this type of scale for measuring satisfaction, patient satisfaction. I can use. So I would say, uh, how is this hospital described according to your feelings, or what are your feelings about this hospital? I'll put. It says, doctors are friendly, doctors are unfriendly, nurses are friendly, unfriendly, messenger staff friendly, unfriendly, diagnostics are very prompt and reliable, they are not prompt and reliable, food and nutrition is good, not good, cost of services is affordable, not affordable, medicines are of high quality, not of high quality. I guess you're getting an idea now. So what happens when they answer to all these questions? For example, you can see I can tick here one, and then I can tick here another, low price. Then I'll tick, see this is, if it is modern, this will be 7. Old fashioned means 1. Low price means 7. High price means 1. Unfriendly means 1. Friendly means 7. So I'm reversing here. So based on the first word, you must know if it is a negative word, you give 1 here. For a positive word, you give 7. So you should know where to give 7, where to give 7 here. So what happens when when a respondent answers, you can see by plotting, it looks like a snake. For example, I gave answer here, 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 and here. So if I plot, it will be like this. It will be like a snake. This is the way you can see. It's a snake. You can see here. It is like a snake. So what I'll do, I'll stop here, take a break 5 minutes, come back. What I'll do this time, I have already recorded the validity and reliability. I will play the record. I think that will be disturbance free because it's a pre-recorded video. So you can just simply listen to and make some notes. I think I have done it very slow. So you don't have to worry about it. So let's have a break now. 5 minutes. 1 5 will be back again. So friends, welcome back. We're going to start with the next part, and it is titled Validity and Reliability of a Measurement. Validity and reliability of a measurement. So once again, we need some kind of pause or short breaks. Because continuously we are listening and noting down, and then of course for me continuously talking is also a bit tiresome, annoying. Because mouth dries up very frequent. I have to take water. I'm also learning how to uh, stream live video. So a lot of lessons are learned from other videos. So particularly when you're on YouTube live stream, you should not be silent. Something or other I have to keep speaking. But I'm learning how to do that. So somewhere you also need some pause, some breaks. Continuously speaking also is not correct actually. So we will slowly what we will do now. I will remove this PowerPoint file and I'm going to play a video which I have pre-recorded on this concept. So instead of again fresh addressing it, I can replay that video which I have done it for my other batch of students. I remember somewhere in the beginning of last month. So if it has a timestamp, just ignore it. So I'll close this file and now what we will do, we'll start the video. I hope it's you can also give me feedback if you have any problem with the video because I'm starting that now. So
Friends,
please
good
check it
morning to all of you.
whether it's
Today we're going to see a new topic, namely validity and reliability. And this is the last class in the series of sessions on the concept of measurement. So far, we had seen the concept of measurement, its importance, and certain rules that we follow in measuring our variables. Now,
and also
what
let
is
me know about
measurement?
the
To
sound.
review, measurement is the process of assigning values to a variable with standard rules. What are those rules? Those rules are also called levels of measurement. In other words, there are four levels of measurement that we had seen in one of those previous classes, namely nominal, ordinal, interval, and ratio. So there are four levels of measurement which are there in this universe. So if you want to measure any variable or any concept in this universe, these are the four levels that are available. In other words, without these four levels of measurement, you cannot measure anything in this world. Besides that, in order to qualify these measurements as the best measurements, we must know what are the four important characteristics of a good measurement that we had already seen. So, to review once again, there are four important qualities of a measurement, namely equivalence, inherent order, fixed interval, and true zero. And we had already seen that nominal measurement does not have all the three qualities except equivalence. So therefore, a nominal level of measurement is not a perfect measurement. Whereas the second one called ordinal measurement. Ordinal measurement fulfills the first two characteristics. Therefore, it is also not a very good measurement. Now, as we move to the interval level of measurement, it fulfills equivalence, inherent order, as well as fixed interval. So therefore, it's a relatively better measurement. And the winner is the ratio level of measurement, which fulfills all the four important characteristics, namely equivalence, inherent order, fixed interval, and the true zero. So therefore, I don't want to elaborate more on those levels of measurements. You can always listen to the previous lectures, which are available online. But today, we are going to see the most important aspect of the measurement, and it's also the concluding aspect of the measurement. So before we move on, let us see once again the process of research. We had already seen step 1 called assessing relevant and existing knowledge, followed by the second step called formulation of concepts and propositions, and the third step is statement of hypothesis, followed by the backbone of research process called research design. Now we are still in the fifth step, namely acquiring empirical data. In that we had already seen the concept of measurement, We had already seen the levels of measurement, and then we are concluding with the concept of measurement today, called the topic called validity and reliability. So let's move on. And before I want to pay attention to certain interpretation rules that we follow in statistics, particularly when we want to measure the relationships between the variables. And I'm sure you would be still recollecting the previous class on statistics, particularly the class on correlation coefficients, how to interpret correlation coefficients. Now, if you see through the screen, you could see that when the coefficient is between zero point 0 to 0.19, we call it negligible relation or relationship. Zero point 0 means no relationship. When the range is between zero point 0.2 and 0.39, we would call it low or less relationship or low relationship. When the coefficient range falls in between zero point 0.4 and 0.59, we call it moderate relationship. Followed by zero point 0.6 and 0.79 is called high relationship, and the last range is zero point 0.8 to 1 point, which is called very high correlation. So we should always be settling down with zero point 0.6 to zero point 0.7 or zero point 0.8 to 1. Normally in social sciences we don't expect 1, so therefore we can always settle down with zero point 0.6 to zero point 0.99. So with this standard rules of interpretation, let's move on with the concept of validity. The purpose for which a scale is designed. In other words, it measures what it actually designed to, the purpose for which it was meant. So now, in order to establish the validity of a measurement, we have to identify which type of measurement is very suitable. So let's move on with various types. The first one is called construct validity. The second one is called content validity, which again splits into two types called face validity and sampling content validity. And the third one is called criterion validity. So these are the three important validity methods or types of validity that are prevalent in the theory. Now, there is also another validity method called predictive validity. We shall see that later on, not in this context. So, but as of now, we will see only three concepts, three types of validity, namely construct validity, content validity, and criterion validity. Let's start with the construct validity. What is the meaning of construct validity? A construct refers to a concept or a characteristic being measured. So, therefore, does that measure really what is the underlying theoretical construct? Or in other words, is this measure really measuring what is hidden or what is the purpose for which the construct is designed? So theoretically identified concept, is it really capturing? So if it's really capturing, then it should be considered as having construct validity. This needs inclusion of items based on theories. So which means when you are developing a scale or a list of questions to measure a particular concept, all these questions must be coming out of standard theories. Each of these questions is an indicator of the concept mentioned in the theory. Let's move on to the next one called the content validity. Does a measure cover all different domains of the concept or all the representative aspects of the concept? If all the questions that you had evolved or designed really covers all the theoretically identified domains of the concept, then it must be having content validity. Now, how do we establish content validity? Content refers to all the questions which are really covering the essence of the concept. So, how do we establish content validity? There are two methods by which, or there are two subtypes by which we can do that. Number one is called face validity. Number two is called sampling content validity. So, what is called face validity? Face validity refers to how suitable the content of a test seems to be on the surface. How is measure viewed by others as covering the concept? For example, you are measuring the concept of customer satisfaction with a set of, let us say, 25 questions. whether all these 25 questions really reflect upon customer satisfaction or not. How are you going to declare that? So instead of you doing it, you give away this 25 question printout to a panel of judges, let us say five experts in the field of marketing or consumer behavior. Ask them to independently review those 25 questions and declare whether all those 25 questions are really covering the content of customer satisfaction. So each judge would independently review them and then send you back all those review report. And based on the review report, you would know whether all those 25 questions are really having um, content face validity. In other words, whether all these 25 questions are really reflecting upon the concept being under measurement called customer satisfaction. So, for example, some judges say that certain questions are not relevant. You better have to see how other judges are reviewing those questions. So, based on their uniform understanding, you can eliminate some of those questions. You can even indicate or you can include some of the new questions. And that's how we establish the face validity, which is purely a theoretical judgment made by those judges. So, therefore, judges are very important in declaring face validity. As we move to the next one called sampling content validity, now, those 25 questions should be called sampled items. Now, you have to double ensure that whether these 25 questions or some 25 sampled items are really covering the theme or the concept called customer satisfaction or anything is left out. So, how do you declare that these 25 items are really the sampled content? So, you have identified various research studies which talk about customer satisfaction. From all those review of literature, you would identify all the items that they had suggested, and therefore you can declare them as the sampled items which are really covering. There's nothing is left out. For example, when I'm conducting a quiz on concept of measurement, this quiz should include all the questions relating to measurement. Nothing should be left out. If nothing is left out, this quiz should be called the complete quiz on the concept of measurement. So, content validity refers to the completeness of all the questions which are really measuring the purpose for which it is designed or the measurement is designed. Move on to the next one called criterion validity. This is a little complicated method, but this is a very, very reliable method of establishing the validity of a measurement. A criterion is an external measurement of the same thing. For example, uh, somebody had already developed a measurement of customer engagement. So let us say Professor X had developed a scale on customer engagement. Now, this particular scale or measurement should be treated as a criterion measurement. And now this validity evaluates how closely the results of your scale or your measurement correspond to the results of somebody's measurement. The example I have already quoted is if Mr. X measures customer loyalty, which is already published in some popular journals, you have also developed another measure of loyalty. So both questionnaires or both scales can be included in the study. After collection of the data, you can establish the relationship between Mr. X measure of loyalty and your measure of loyalty. So when there is a high correlation between both measures, then we can declare that your measurement has criterion validity because that professor's measurement is already well established and published. When it is published, it is universally acceptable. So against the well established measurement, you are declaring your measurement is also reliable, I mean valid. And this is what we call criterion validity. Now, we move on to the next concept called reliability. So, having established the validity of a measurement or a scale, we must also establish the reliability of a scale. If validity refers to the purpose for refers to a measure which measures the purpose for which it was designed to measure, reliability refers to the accuracy of the measurement or how consistently the scale measures what it is supposed to measure. Or can it repeatedly measure what it is supposed to measure? In other words, can it reproduce the same result? So this is also called internal consistency. This reliability is also referred to as internal homogeneity. And finally, it can also be called dependability. To simplify further, validity refers to a measure measuring what it is supposed to measure, or what it is measuring, what it is supposed to measure, or what it is intended to measure, or a scale measures the purpose for which it was designed, whereas reliability refers to the consistency of that measurement. So the first one refers to accuracy of the measurement, how accurately it measures, whereas reliability refers to how consistently it measures what it is supposed to measure. Consistently means, if yesterday's scale is valid, is it still valid today? If it is repeatedly being valid, it should be treated as reliability, in other words. So it can consistently produce the same result 100 times, then it should be treated as reliable. So we must also establish the reliability of a scale. But there is always a question, should we always establish both of them, validity as well as reliability? Not necessary. Once a scale is already validated, you need not redo the validity. Suppose I'm adopting some professor's scale meant for customer loyalty. I don't need to establish its validity because that professor has already established the validity of that scale. What I have to do is, in my research study, I have to only produce the reliability of that scale, because is it consistently producing the same result? He had already established its accuracy, but I want to know whether it is really reproducing. So that's why in my study, when I'm adopting somebody else's scale, I must be able to only establish the reliability of the scale. So let's various types of reliability. Before that, let us once again review. Validity refers to the accuracy of a measurement, whereas reliability refers to how consistently the measure is accurately measuring. So here the word consistency is very important in understanding what is called reliability. More so, reliability also refers to a measure which is free from all kinds of errors. So error-free measurement is also called a reliable measurement. So now let's move on to various types of reliability. The first one is called test-retest reliability. The second one is called inter-rater agreement reliability. The third one is called internal consistency. So these are the three methods of establishing reliability of a measurement. So while you're doing your summer project, you may have to establish the reliability of the measurements or the scales that you have either adopted or adapted into your studies. So let us start with the first one called test-retest reliability. Now, test-retest reliability, I have already mentioned in the brackets that you would be employing or applying this test on same sample at different times. So test, retest. You can at least do it two times. So pick up a questionnaire consisting of 25 items and customer satisfaction. Employ it or administer it to a sample of customers today. And then after a gap of 15 days or 30 days, try it again on the same sample. So you will have two databases. And then that's how you conduct test retest reliability. When you got two databases of same people in two different times, you can run this reliability test. In the second type, which is called inter-rater agreement, which is also sometimes called parallel forms, or two same tests, same people, same time. So what does it mean? You can pick up two scales, like I've already told in the previous example of validity, that some professor's scale on customer loyalty and your scale on customer loyalty. You can join both the scales in your questionnaire. So your scale consists of, let us say, 20 items. That professor's scale consists of 25 items. So totally 45 items. Put all 45 together in the questionnaire. Collect data from the same customers at the same time. Now after coming back, you segregate these questions, your 20 questions and that professor's 25 questions. Both are measuring customer loyalty. Try to establish the reliable correlation between two sets, your set of 20 questions, professor's set of 25 questions. So when you establish correlation between them, you are basically conducting inter-rater agreement. The last one is called internal consistency, which is also called split off. This is the most popularly used reliability assessment across the world. It also refers to how consistently the answers were given by the respondents to all the items or questions that are included in your questionnaire or interview schedule. So, I would like to elaborate more on these three methods as we move on to the next slide onwards. Let's start with test retest reliability. So, let's try to understand how we do it actually. An assessment or test of a person should give the same result whenever the test is conducted. So, since reliability refers to consistency or consistently producing the same result, so test to retest means here we are trying to conduct twice the same study or using the same, I would say, the measure or the scale. Now, same people, different time. That's what we call. Over the time, is this measurement very stable? So, reliability also refers to stability of the scale or the measurement. So, in the development of a test, a class of children are given several tests that are intended to assess the same abilities. A week and a month later, they are given the same test. So, what happens? You have at least two scores. Before the commencement of the class, one test score, and then after the completion of the class, after passage of 1 week or 1 month, I'll conduct the same test. Now I have two data sets, before the classes, after the classes. So when I would find that the relationship between these two scores is high, that means this test has is reliable test. That's the way I can do it. Same, we can even try another example. If I'm conducting a quiz on research methods, which is conducted twice in 2 weeks, assuming first quiz is X and second quiz is Y. So I have the score of X and score of Y. And when I establish the relationship between these two, I am actually conducting test retest reliability. I am establishing the test retest reliability of my quiz. Let's move on to the next one called inter-rater agreement. We are using actually different samples at the same time. So what does it mean? Inter-rater reliability thus evaluates reliability across different people. For example, let us say I am conducting a test of student satisfaction in section A and section B, same time, and identify relationship between two group scores. This means section A class score and section B class score on the same measurement called student satisfaction. If the relationship between section A and B is very high, then I would say that there is an inter-rater agreement reliability. This can also be done in different ways. For example, I can divide the section A class into two groups randomly. So which student would go into first group, which student would go into second group, I would never know. But once they are classified into two groups, I would give them the student satisfaction measurement. So when they answer it, I'll collect all those answers and establish the relationship between Group A scores and Group B scores. I am establishing inter-rater agreement in one class itself. As I have already shown you that I can also run this in two classes. Section A score is called X, Section B score is called Y on customer satisfaction. Establishing the relationship between these two scores also would be treated as inter-rater agreement. Now, the other names for this type are also called inter-observer reliability or inter-coder reliability. If you are interested, you may read on your own or refer to your textbook or go online and search for these two concepts. Now, inter-rater agreement also is sometimes treated as another form called parallel forms. So here what we do, two same tests similar to criterion validity where one professor's scale on loyalty and your scale on loyalty. It follows the same assumption. In parallel forms, what I would do, I would include two scales that are measuring the concept or the research idea. Supposing if I'm measuring customer engagement using somebody's standardized scale and I'm also developing my own scale, so both scales are put in one questionnaire that is given away to respondents. when they give me answers, I would have two forms, scores, Professor X score and my score. So when I establish relationship with these two scores, I'm actually conducting parallel form reliability, which we have already seen in the previous slide, namely item discrimination index, item difficulty index. Item discrimination index is also called the power of discrimination of the item, and then item difficulty. How difficult the question is when it's put to the respondents. So item discrimination index, item difficulty index, these are the two methods that are uh, adopted to establish the of each item that goes into your final scale. So let's move on. Item discrimination index is a measure of how well an item is able to distinguish between examinees who are knowledgeable and those who are not. So who is good and who is not good in the subject can be established using item discrimination index. Discrimination index, when we calculate, would give you a range of -1 to +1. Negative means measuring something else. So therefore, this measure this method would establish the reliability of each question, whether each question is really discriminating the respondents into two extreme groups. Now, the next one is called item difficulty index. It is a measure of the proportion of examinees who answered the item correctly. So, how many people can really answer to one question correctly? If good number of people answer it, it is not difficult. It's very easy. If a large number of respondents are answering this question so easily, that means the difficulty is very less. So the the difficulty index is ranging between zero point 0 and 1, with a higher value indicating that a greater proportion of examinees respond to the item correctly, and it was thus an easier item. So let's move on to the next one called item-item or inter-item correlation. Item-item or inter-item test correlation is also established using Pearson's correlation coefficient, calculated for each pair of items or item and the overall score of number of questions including number of items in a particular scale. The higher the coefficient, the higher the reliability. So therefore, it is also called inter-item agreement method. In other words, when we establish correlation between pair of items in a scale of 25 questions, let us say, so 25 scales means 25 scaled item refers to 12 pairs. If each pair has a correlation, similarly in the combination, other pairs also have correlations, then I would say that all these 25 items are really measuring consistently the purpose for which they were designed. We move on to the last method called split off or internal consistency method. Internal consistency method consists of two sub-methods, namely split off method and Cronbach alpha method. In split off method, we have three types again. This can also be demonstrated using the software. In one of the classes, I will demonstrate using that software. So in split half method, we will split our scaled items into two halves. That first one is called balanced halves. For example, I have developed a scale to measure customer loyalty, which is consisting of 25 questions. So these 25 questions will be equally divided into two halves. That's why it's called balanced half. The first 12 items, the remaining 13 items. So what I would say, I'm splitting the scale of 25 items into two halves, namely first 12 items and the last 13 items. After collecting the data from the respondents, I'll try to establish the reliability coefficient or the relationship between the first half and the second half. And whatever the coefficient as a residue, I would declare it as having reliability. The second method under split off is called random offs. So I can divide all these 25 items into two offs by choosing these questions or items randomly. So when I choose the first half and the second half randomly, I'm still trying to establish the correlation between these two halves, and that is also called split off method. And the last one is called odds evens method. This is also another type of split off. Here what I would do, all these 25 items are listed and I'll pick up the odd numbered items and the even numbered items. Odd numbered items is first part, first half, even numbered items is second half, and then establish the relationship between these two halves, which is also uh, gives me internal consistency coefficient or reliability. Now, we move on to the last method called Cronbach alpha method. Cronbach is the name of a professor who had invented this method, which is the most reliable or most robust method of establishing reliability of a scale. Now, how do we do that? In fact, in most of the research studies, we see authors mentioning Cronbach alpha coefficient of all the measures that they had adopted or adapted into their study. Now, what does this alpha means? Alpha method is an extension of split off method. We must remember that first. Now, what does it mean? In Cronbach alpha method, we will try to take the average of coefficients of all the split halves which are made possible. For example, if I'm measuring customer loyalty using 25 item scale, how many halves I can divide? In the split off method, I have seen three methods, sub methods. So at least three times I can divide them into halves. So if I take correlation coefficient of balanced halves, correlation coefficient of random halves, correlation coefficient of odds evens halves, at least I have three coefficients. I can divide those three coefficients after taking the sum of coefficients, and then I would get the average of those three methods or three halves, three times. Now that's exactly called the average of coefficients of all the splits of made possible. We can even use permutations and combinations using NPR and NCR formula that you can refer to online to arrive at all the possible split offs. In other words, how many times you can divide these 25 items into halves, two halves. Now you can have as many as possible. So once we establish the number of halves and establish the correlation between all those splits halves, take the average of all the split halves, divide by the n, then you would know the coefficient of reliability, and that's what we call alpha method, which is the most robust method of establishing the reliability. I think that's all for now. We have concluded with validity and reliability. In case if you have any doubts, you can revert to me either through WhatsApp messages or through emails, or you can even call me. And in the next class, we're going to see designing tools of data collection, which is a very, very important topic. And with that, we would be finishing. I think we would be partly finishing acquiring empirical data as a fifth step in research process. And once we finish off with the designing tools, we would be moving on to the concept of sampling, and then that's it. Once we are through with the sampling, we have to learn to collect the data, enter the data into computer Excel sheet formats, then start using softwares like SPSS and other statistical softwares. I'm going to introduce a new software to all of you, and then you can also install it and learn. That's going to be in the subsequent classes. So until then, I wish you all the best. Happy learning. In case if you have any doubts, again come back to me. Have a nice day.